So welcome to this Munch and Learn for March. This is our third Munch and Learn session this year. We started this program a year ago. My name is Didier. I'm the tech lead for the HP Developer Community Program. And today I'm really pleased. We have a huge crowd here. We have a team, a good part of the Mithril engineering team with us today. And they will be talking to us about Mithril, Project Mithril, which is about introducing some robust identity into service mesh Istio by integrating with SPIRE. So before I go on and provide them with the mic, let me go through a couple of little pointer here. We have people from our team. I think Denis is probably here and Patrick as well to help you with the links. So we will put all the links in the chat. But we started, as I said, this Munch and Learn about a year ago. We have a calendar for those. You can register there, and you can also find the replay link, which we will make available in the coming week. In addition to the Munch and Learn, we also have another monthly program called the Meetups. And this is a new series that goes into in-depth, specific, if possible, open source technology. And you can see some of the topic we covered in January and February. We started this program only in 22. So we started with a Quarkus session delivered by Red Hat, another one on Streamlit delivered by Streamlit. And we're going to have one next week on vfunction. And then the following one will be on Open Policy Agent from the company SPIRE. So feel free to also join these if they're of interest for you. So these are meetups. We call them meetups. And again, you can register there, or you can find the replay link for those. We call these Munch and Learn because we don't know exactly what time it is, where you are, and maybe you're having lunch, maybe dinner, or maybe just a munch. So we call them Munch and Learn. And what is fun is if you want to share your munchies, take a picture, use the Slack, for example. We have a Slack workspace where we have a dedicated channel for sharing our munchies over the different sessions. So feel free to participate there. Or you can also share on Twitter using the hashtag HPDev. So feel free to participate with us. If you want to join the HPDev community, feel free. There are several ways you can join that through Twitter, through Slack. I mentioned that already. We have a monthly newsletter as well, so you can keep up with everything we do. So feel free to scan that QR code and take a look there and pick your preferred way to communicate. Our website is hpdev.io or developer.hp.com is our main website. So take a look and you'll find all those links there. Otherwise, you'll find them in the chat. During that session, you'll be able to use the Q&A to ask questions. We have a large panel of engineers to help answer the questions. We'll keep time at the end to make sure we have answered all the questions. So we have the Q&A and the chat. If possible, for questions, put them in the Q&A. It's easier for people to spot, for panelists to spot the question and provide an answer for everyone. But you can also use the chat to discuss and share. Okay, and we will also have a poll, which I will launch in just a few minutes for you to answer, so we understand better what kind of an audience you are. Thank you very much. With this, I will hand it over to Pranita and for the real session and stop sharing my screen. Thank you.
Hi, everybody. Thank you for joining us today. My name is Pranita Mantrawadi. I'm a product manager in HP's Security Engineering Group. Joining me today are my colleagues from engineering. Next slide, please. We are a globally distributed team of engineers, architects, product and program managers, and technical writers. We partner with other HP teams to understand the security needs of their users. These learnings and observations allow us to architect, develop, and deliver a loosely coupled platform security services that we implement across our HP solutions, but we also make them available as open source so our customers can build their own solutions. Next slide, please. As HP works to accelerate business outcomes for customers with comprehensive solutions from edge to cloud, We're also learning from our customers just how complex their architectures are evolving and how securing them is even more challenging. There are lots of moving parts that must be secured. On top of that, with the rise of containers and adoption of microservices-based architectures to accelerate digital transformation, cybersecurity teams are facing larger attack surfaces and increasingly low-level attacks. These are adding to the challenges with adopting end-to-end zero trust security that can scale easily, particularly in such distributed and heterogeneous environments. In addition, the workloads in some cases are not persistent. So it becomes increasingly crucial to scale security of such workloads by standardizing how systems define, attest, and maintain software identity, regardless of where these workloads are deployed. Our group is one of many at the company who believe that as our customers evolve towards adopting cloud-native architectures, open source software is increasingly becoming a critical dependency, whether it be in networking, security, or observability. From a security standpoint, we are leading the way with our continued involvement and leadership within the SPIFFE and SPIRE projects, both of which are part of the Cloud Native Computing Foundation. I will now hand over to our team to talk about SPIFFE and SPIRE's standardized identity framework with flexible and interoperable plugin mechanisms that allow it to deliver and manage workload identities across multiple platforms. We'll also cover how we complement Istio's authentication to provide more robust and flexible attestation beyond Kubernetes namespaces and service accounts, which currently is a limitation of Istio's attestation capability. Over to you, Max.
Thanks, Manita. Hello, everybody. My name is Max Lambre. I'm a software engineer at JP and a SPIFFE contributor. Yeah, this is our agenda for today. So before talking about what we have been working on, we'll introduce technologies and concepts that are the foundations of our work. We'll do an overview of Zero Trust, SPIFFE and SPIRE projects, and we'll talk about service meshes, and specifically the most popular one, that's Istio, and then how SPIRE can be integrated as the identity control plane into Istio. Next, please. Yeah, let's begin by doing a quick recap of how security has been done historically. The model that predominated is known as perimeter-based security, where we have a well-defined perimeter and its premises. Everything inside the perimeter is implicitly trusted and everything outside is untrusted. This model works basically by deciding which apps, users, and devices are allowed inside this corporate firewall and blocking those that are not allowed based on IP address. Next slide, please. So then with the advent of the cloud and multi-cloud and hybrid cloud applications, remote devices, microservices running in container orchestrators, the perimeter becomes increasingly difficult to define and to defend. So this castle and moats model doesn't work in implicitly complex environments. It's like to protect a 21st century infrastructure with a model from the Middle Ages. And we're seeing to what extent this model is critically flawed in the face of many modern threats. The number of cyber attacks is skyrocketing. And just in the US in 2021, there were almost 1,800 cyber attacks. And that's an increase of more than 60% in comparison to 2020. So we need a new model, a different model, a different mindset to address security. Next. Yeah, and here comes Zero Trust. It's a security model based on the premise that no one is implicitly trusted based on the network location. It's a fundamentally different mindset, and Zero Trust is basically the practice of removing implicit trust through strong identity and policy. Under the Zero Trust concept of never trust, always verify, every application, user, and device must prove its identity before every session, and once authenticated, only gets least privileged access to connect to other assets in the organization. Identity has become the new perimeter. Having strong identities, it's a fundamental tenet to adopt and implement the zero trust model. Because with the zero trust model, we need to identify and verify every service or workload running in the organization. The IPs are no longer enough. That the service runs on a specific host with a specific IP is not enough to trust it. We need a more fine-grained method. We need to be able to use more data and more mechanisms to attest entities connecting to our corporate assets. And here, SPIFFE comes to help. SPIFFE is a secure production identity framework for everyone. That's the acronym. SPIFFE is a set of open source standards for software identity. SPIFFE defines interfaces and documents for obtaining and validating cryptographic identities in an automated way in heterogeneous environments. SPIFFE can be used as an identity framework for minting and distributing these identities in this very complex environment. In this environment, having services running on multiple clouds and on-prem, we will not have a perimeter defined by a firewall, but instead every service will be attested and get its identity, and will be able to verify others and be verified in each connection. I just mentioned what are the components of SPIFFE. The SPIFFE ID is how a service name or identity is represented. And here I'm using service, workload, application interchangeably without a strong and specific definition. Then we have the SPIFFE verifiable identity document, the SVID. It's a cryptographic verifiable document used to prove a service identity. And currently, SPIFFE supports two formats, JOT tokens and X-Finance certificates. Then we have the SPIFFE workload API. That's a simple node local API that services or workload use to obtain their identities, their credentials without the need for authentication. Then we have the SPIFFE Trust Bundle. It's a format for representing a collection of public keys in use by a given SPIFFE authority. And SPIFFE Federation. It's a simple mechanism by which trust bundles can be shared. SPIFFE Federation enables the authentication of identity credentials across trust domain. And here, trust domain is another very important concept of SPIFFE. Trust domain are used to manage security boundaries within and between organizations. Trust domain is a portion of the SPIFFE ID namespace over which a specific set of public keys is considered authoritative. This means that different trust domains have different issuing authorities and have different public keys. In other words, the trust domain corresponds to the trust root of a system. A trust domain could represent an organization, environment, department running their own independent infrastructure. And all workloads identified in the same trust domain are issued identity documents and the credentials that can be verified against the root keys of that trust domain. And what is SPIRE? SPIRE is a production-ready implementation of all the SPIFFE standards. So we will do a quick review of SPIRE. SPIRE has two major components, the server and the agent. The server is responsible for authenticating agents and minting all the SVIDs in the trust domain, while the agent is responsible for serving the workload API. Both components are written using plugin-oriented architecture, so they can be easily extended to different configurations and platforms. Here we have node attestation. During its startup process, the agent proves the identity of the node he's running on to the SPIRE server. This is usually done by leveraging the platform API, for example, using the AWS or GCP metadata API. And through this process, the agent gets its identity from the server in the form of an SPIFFE and X-Finance certificate. And once the SPIRE agent is running, it exposes the workload API to the services running on the same node. And when a workload data service calls the workload API, it explains a process that is called workload attestation. This is the process of verifying the identity of the workload running on the node. The workload connects to the agent to get this identity, and the agent inspects the process, calling and obtains information, for example, from the kernel about that process, about the workload, and get some selectors, some information about the workload, and then using those selectors, define which identity it has assigned and that workload is entitled to receive. The agent delivers the identity to the workload in the form of a finance certificate or short token having a specific SPIFFE ID for that workload, and also it will deliver a private key associated and a set of trust bundle for that trust domain. And then having all those credentials, the workloads can establish mutual TLS communication using their identities. I will give a quick overview of the SPIFFE Federation. The SPIFFE Federation enables authentication of the identity credentials across trust domain. In this example, we have 2 trust domains. Each one has its own set of public keys, and the workloads in one trust domain wants to connect to workloads in the other trust domain. And we can configure SPIRE servers to federate with each other and share the public keys through a bundle endpoint. This way, when the workload asks for their identities, they will get the trust bundles for both trust domains, so we'll be able to verify workloads from the other trust domain. Here in this example, the workloads will be able to establish a mutual TLS connection with the workloads in the other trust domain. So Zero Trust and the proliferation of microservices have spawned the immersion of tools to deal with these complexities involved in managing perhaps thousands of, hundreds of thousands of services, identities, and policies. And being service meshes, one of the most popular. Now, Giuliano will give an introduction to service meshes.
Thank you, Max. So my name is Giuliano Fantozzi. I'm a member of the Mithril team as well. And as Max said, now let's talk about service meshes. Sorry if there are any service mesh experts here. I'm just going to give you a brief introduction, so bear with me here. Right. So to better understand the context around service meshes, I think it's valuable to review the timeline. You can move to the next slide, please, Alex. I think it's valuable to review the timeline of software systems up until now, right? So then we can elaborate on why something like this is relevant right now. So we didn't start by making software systems. We didn't start with distributed systems, right? This is not something intuitive to build, and you wouldn't build that without a very good reason for it. So I'm emphasizing this because building a distributed system is not something we have been doing historically, we haven't been doing for a long time. So it's not something we're super mature on it, right? One can say that for container orchestration, we have a good level of maturity, right? I believe probably, if not all of you here know Kubernetes. So a technology like Kubernetes solves what I like to think are the first problems you will have when having to deal with distributed architecture in an infrastructure level. So I'm talking about provisioning your containers, scaling them, restarting, providing basic networking, and so on. But when you get further in the game of the distributed systems, you find out that you have a lot more other issues to tackle. I'm talking about complex traffic routing rules like circuit breakers, timeouts, retries, or problems regarding observability, like having a distributed tracing and centralized logs. These are problems that a service mesh deals with. A service mesh is actually built to solve and address all of these, at least the most common of these issues at once. Next slide, please. So before service meshes were actually seen as a separate piece of infrastructure, everything was tied to the application code, to your business code. So many design patterns emerged and everyone started implementing their own localized tiny service mesh to suit their needs. And that, that used to be completely tied again to the application code. And this led to many issues, and people figured out that this deserves a more definitive and robust solution, right? So currently, the most popular way to achieve this is through an architecture of deploying one independent proxy, usually called a sidecar, for every application in your system. And that proxy will intercept all inbound and outbound connections that service makes, while still applying all the logic we would want to those connections. Building this logic into a separate piece of software has more security benefits over the more traditional approach of implementing all these features tied to the application. For instance, now you have the ability to redeploy your sidecar without having to affect the application state. This facilitates for ensuring and pushing updates to allow having the same version of your sidecar everywhere in your system. With newer proxy implementations, it also allows you to dynamically configure many network parameters and having that applied almost instantly with no need for restarting anything. This is specifically handy as these environments tend to be in constant change. And finally, the meshed centralized control aspect allow for security teams to build policies that will apply to the entire organization with ease. This, tied to the service mesh ability of encrypting every connection, increases the security for every application by default. And although there is a lot more to talk about service meshes, I'll now give the word to Caio, who's going to be talking about Istio, today's most famous service mesh.
Thanks, Juliano. Hey, everyone. I'm Caio Milfon. I'm also a Mithril, I'm part of Mithril team. And I'll be talking about a little bit about Istio, that is the most popular service mesh that is today. So what is Istio, right? Istio is an open source service mesh that goes on top of your existing distributed application. It has some powerful features to provide a more uniform and efficient way to secure and connect your services. It has the ability to add load balancing, service-to-service authentication. It can add monitoring to your services without little to no code changes on your service. It is designed for extensibility, so it can handle a large number of deployment if needed. And it also has a large ecosystem of contributors, partners, integrations, and it has a lot of variety of scenarios that it can be used. So Istio has mainly two components in the proxy. The two components are the data plane and the control plane. The data plane is basically the communication that happens between the services. Without the service mesh, the network cannot understand the traffic that it's been sent over and can make any decisions based on where the traffic is coming from or where it's going to. So the proxy actually intercept all your network traffic and allow a broad set of application-aware features based on your configuration. In your configuration on Istio lies on the control plane that it actually takes that desired configuration that you put up and dynamically programs the proxy servers to update them as the rules or environment variables are changing or anything that you want to add. You can go to the next, please, Alex. Thanks. A little bit about the Istio identity and certificate management happens with this provisioning workflow. I'll be briefly talking about this, and Alex will be more, we'll talk a little bit more about how we affect this. Basically, Istio offers a gRPC service that takes CSRs, that stands for certificate signing requests. And then when the Istio agent creates the private key and the CSR, it sends them to Istio so it can sign. The CA that lies within Istio validate the credentials carried over the CSR. And then when it validates, it signs and generates a certificate. And then when the workload is started, when your service is started, the envoy, that is the proxy, it requests the certificate and the key from the Istio agent via the SDS API, that stands for Secret Discovery Service. And then Istio agent sends their certificates received from Istio to envoy via the SDS API. That's basically the certificate management in Istio. And one key thing here that I like to mention is the attestation capability of Istio today actually happens over service accounts and namespaces. And that's where Mithril comes in. And I'll pass the word to Alex so he can talk a little bit more about the project itself.
Thanks, Caio. Hi, guys. I am Alexandre Alvino. I am also a member of the Mithril team. And so for the integration, should we only consider Kubernetes namespaces and service accounts when trusting a workload, as the issue does? Could we improve Istio security by enhancing its attestation process? So that's where Mithril comes in. The project integrates SPIRE with Istio, allowing the service mesh to leverage all SPIRE capabilities. SPIRE attestation can consider multiple trusted parties before issuing an identity for a workload. In addition to verifying a combination of Kubernetes metadata, such as namespaces, service accounts, and pod labels, SPIRE can involve host operating system information, such as C group and UID of the process running, container runtime, for example, the container image name or the hash of the workload binary, or even verifying a private key stored on a hardware security module or a trusted platform module attached to the node. SPIRE provides a unified identity plane solution that can traverse across multiple heterogeneous environments and platform boundaries. With SPIRE, you can manage identities for workloads running on VMs, Docker containers, cloud services, or even workloads running on bare metal. Besides improving Istio attestation process, Mithril gives to the service mesh SPIRE's pluggability characteristics. You can develop your own plugin to extend the attestation functionality to fit your own environment. With Mithril, Istio has also the power to federate SPIFFE bundles, enabling secure communication on a multi-tenant architecture. With Mithril proposed design, Istio can be configured to use SPIRE as a certificate authority for issuing identities for workloads inside an Istio mesh, allowing the envoy proxies to communicate directly to the SPIRE agent through the SDS API. After the detection of a running SPIRE agent instance on the node, Istio agent will not generate a key pair to present to Istio in a certificate signing request, and instead it will rely on envoy to fetch the identity from SPIRE through the SDS API. On its startup process, envoy will try to fetch cryptographic materials on behalf of the workload. SPIRE agent will then begin the attestation process. And after it's done verifying all required parameters, It will then present an identity for the workload to be used by Envoy to securely communicate to other services. Our remaining Envoy XDS related configurations are still managed by the Istio control plane. Here's an overview of identity and certificate management in Mithril. All services inside the mesh have their secrets managed by the SPIRE deployment instead of Istio-D. In the Mithril architecture, each Envoy proxy is fetching a certificate through the SDS API on behalf of the service running on the same pod. Service here you can see service A and service B, and all of them, including service C, belong to the same trust domain, meaning that their certificates, their identities were issued by the same SPIRE server. And by that, they can all securely communicate with each other with MTLS connections. So for this Mithril demo, I've prepared a set of scripts and YAMLs to showcase the SPIRE and Istio integration. First of all, we need to, I will follow some steps. We'll deploy SPIRE and then Istio, so Istio can detect a running instance of SPIRE. Then I will deploy an example workload, create SPIRE registration entries so that the SPIRE can issue identities for trusted workloads. And then I will verify that the certificates were issued by SPIRE. So let's get into the demo. Right here, to save some time, I already have a cluster running with SPIRE deployed. Here we can see a pod for the SPIRE server and a SPIRE agent running on the node with additional containers to share the volume amount of the SDS API, so the workloads can communicate directly to the SPIRE agent. So let's go to the next step and deploy Istio. So this will deploy Istio-D and Istio Ingress Gateway with the Mithril implementation. Let's deploy the example workload as well. Here we are going to deploy the Sleep app, a well-known example app for the Mithril community to illustrate this integration. Let's check right now the pod state. Here we can see that the Istio agent didn't reach the ready state. So let's take a look at that. So right here, we can see that Istio agent startup and detects a SDS socket, that is the SPIRE agent socket. And it won't start its own SDR server to serve identities issued, signed by the Istio-D. And instead, we rely on the Envoy proxy to fetch the identity of the workload from the SPIRE agent. Here we can see that the Envoy tried to do that, but was not able to, because we haven't registered an entry for that specific workload on our SPIRE server. So let's go ahead and do that. Here I will execute some scripts. I will first register the SPIRE agent running on the node. Then let's register the Istio Ingress Gateway. And then register the example workload. So let's take a look at some, or take a look on the entries that we created on the SPIRE server. So right here, I used a command to showcase the entries that we have on our SPIRE deployment. We can see here that we created one for the sleep app, one for the ingress gateway with this SPIFFE ID, and one for the SPIRE agent running on the node. And we can see here that we used a couple of selectors or parameters to verify on the attestation process. For the sleep, we used Kubernetes namespace and Kubernetes pod UID. For the ingress, we used Kubernetes namespace, the pod UID, and service account. But we, to facilitate this demonstration, I only used those selectors, but you could apply more selectors on your environment. You could maybe attest a private key on a TPN module and attest that a workload it's running on a piece of hardware that you trust. So let's check again the pod states. Right here, they all reached the ready state. Let's check up again the logs. So after we created a registration entry for this workload, Envoy was able to fetch an identity for it and finished its startup process. And now it's ready for using that certificate for MTLS connections. So what we can do as well is to take a look at those certificates and see if they were issued by SPIRE. So I will copy paste the command here to write the certificate of the sleep example workload to a file, and then let's inspect that 509, the X509 certificate. Here we can see the encoded PEM, and let's inspect the certificate here, the X509. Here we can see it was issued by SPIRE with this SPIFFE ID and this trust domain. So we can see that the workload belongs to the same trust domain of the SPIRE server running on the node. And by that, we verified that the certificate used by the workloads within the mesh were issued by our SPIRE deployment. And that's about it for the demo. Let's get back to Mithril. The current Mithril state is that we proposed the integration of securing the data plane of Istio service mesh through the Envoy SDS API that we discussed, and we submitted a PR, and it's at the review stage right now. I will pass the word to Max Lambrecht again.
Thank you, Alex. So, as Alex said, we submitted a PR to Istio with this integration. We have been having conversations with the Istio community and got favorable feedback. Once the PR is accepted and merged, we will continue the integration by making all Istio components get their identities from SPIRE. We'll make that the Istio control plane be attested and get their identities from SPIRE. And another future work is to allow flexible SPIFFE IDs in the mesh. So currently, we are sticking to the standard SPIFFE ID pattern that is using namespaces and service account. But in the future, we want to allow any flexible SPIFFE ID as is supported by SPIRE. Yeah, thank you. Here you can find the design document that we share with the Istio community and has been discussed. The implementation SPIRE, the documentation PR, we submitted to Istio repos. And we can find also the Istio documentations and SPIRE, SPIFFE and SPIRE docs. Yeah, we have some time for questions. I see that there are some already in the QA. Will we answer them?
We have a lot of good feedback in the Q&A. I think we will do a follow-up session maybe in the second part of the year once this has progressed in the Istio open source project. And that was a great demo. Thank you. Any closing remark from anyone from the Mithril team?
No, I think, yeah, we are here to, I know there are still questions coming in, but yeah, please feel to reach out to us, after if you have any follow-up questions. And there are lots of questions around making the demo available. We'll see, if we can do that. Yeah, thank you.
Yeah, about that, we have a recorded demo, so I don't know how can we share, if you can on the
we will make the recording of the session, which includes your demo, Alex. Let's say in a week or so. So okay. We will make that available on our calendar page, and we will send a follow-up email to attendees to let them know about it. Okay.
Okay.
Well, I think we can close the session. Thank you very much, everyone, Pranita and the rest of the team. It was a great and interactive session. Lots of speakers, so we know you all. And thanks to everyone for attending. I will close the poll and I will close the call. Thank you very much.
Thank you.
Good to hear. Thanks, everyone.
Bye-bye.
Thank you. Bye-bye.